Good morning everyone. Today we are going to learn this reaction when reactant A is react with B to produce the product. So there are three aspects of reaction. One is whether this reaction is feasible or not, or how much amount of product you will obtain, that explained by the thermodynamics. Whereas rate of reaction and mechanism of reaction is explained by chemical kinetics. So during this course of the reaction, the concentration of the reactant decreases. That's why its rate is represented by negative sign. That is, decrease in the concentration of the reactant with respect to time, nothing but the rate or speed of the reaction. So today what we are going to learn, so what is chemical kinetics? Different parameters, factors that affect on the chemical kinetics rate, that we are going to learn. So what is meant by chemical kinetics? Chemical kinetics is a branch of physical chemistry which deals with the study of rate of chemical reaction, mechanism of chemical reaction, and factor affecting on the rate of chemical reaction, that's studied by the chemical kinetics. So let's take various factors. So concentration of the reactants. If we increase the concentration of the reactant, so more is the concentration, more is the frequency of the collision, and as a result into the rate of reaction increases according to the collision theory. And another one, if we consider law of mass action, let's say for example rate is equal to, consider this reaction, A is the reactant and B is the reactant, and stoichiometry relates to A and B. So K is a rate constant. So rate is directly proportional to the concentration of the reactant, can be explained by the as increase the concentration, increase the rate of reaction, can be explained by law of mass action. Then temperature. As you know that temperature will play the important role for the determining the rate of the reactions. For example, have you ever wondered why milk spoils more in summer than in winter? The rate of spoilage of milk is faster in summer than in the winter. Also, there are some medicine which show quick result, and while there are other medicine which take longer time, that is due to the temperature and activity. So more the temperature, more the bacterial growth will be there. And then next parameter is catalyst. Catalyst is a substance that can alter the rate of chemical reaction without being consumed. There are two types of catalyst. One is the positive type of catalyst and second is the negative type of catalyst. So positive type of catalyst increase the rate of the reaction by minimizing the activation energy, and as a result into increase the rate of reaction. For example, if we say example is decomposition of hydrogen peroxide in the presence of MnO2. MnO2 is a heterogeneous catalyst to use hydrogen and oxygen gas. Without MnO2 it takes time, but when we use MnO2 as a catalyst, so rate of reaction increases, and as a result into the rapid decomposition of hydrogen peroxide into the hydrogen and oxygen. Then surface area. The smaller the particle size of the reactant, bigger is the surface area. And if the surface area increases, reactive sites, active reactive site increases, and as a result into increase the rate of reaction. For example, if you dissolve cubes of the sugar into the water and powder of sugar into the water, so rate of dissolution of the powder in the sugar will be faster than that of the sugar, which indicate that, which further support that increase the surface area, which result into the increase the rate of the reactions. Then nature of the reactant. The nature of the reactant is very important. The rate of reaction also depends on the nature of the reactant. For example, let's say if we add iron nail into the water, so rusting process it will take longer time. Whereas if we add sodium metal into the water, explosive reaction will be taken within fraction of second. So this reaction is very fast. So there are reaction types. Some reactions are extremely fast and some reactions are extremely slow. In between that, the reaction is reaction are called as a moderate type of reaction that can be performed in the laboratory. For example, hydrolysis of methyl acetate into the acetic acid, and that can be monitored by titration with the sodium hydroxide in the laboratory, that is called as a volumetric titration. So here what we measure? Change in the concentration with respect to time. So then pressure. Pressure is like a concentration. So in case of the gaseous molecule, if we increase the pressure, volume of the molecules decreases. So the molecule will come closer and closer, and then effective collision will increase. And that's why if the pressure increases, the rate of reaction is increases. For example, Haber process, when nitrogen react with the hydrogen to give ammonia. So this reaction is very fast in case of the high pressure reaction. So let's summarize what we have learned today in this lecture. So what is the difference between the chemical kinetics and thermodynamics? Thermodynamics give us idea whether this reaction is feasible or not, whereas chemical kinetics give us mechanism, rate of reaction of various factors that affect the rate of reaction. In summary, concentration of the reaction increases, rate of reaction increases, temperature increases. If suppose, for example, if you increase temperature, rate of reaction increases. Suppose if you increase the temperature 10 degrees Celsius, the rate of reaction is double or triple. Then catalyst. Catalyst is a again vital role. Catalyst decrease the activation energy, thereby increase the rate of reaction without changing the product. So surface area, again particle size is smaller, then surface area is bigger, so it provides more active sites, and as a result into increase the rate of reaction. And nature of the reactants, ionic reactants ionic compound shows faster reaction and as compared to the covalent character, because in covalent character bond breaking and bond formation it takes time, but in ionic reactions, so ions are easily available. And then pressure. So pressure, nothing but like concentration. In case of the gaseous molecule, we use the thermal pressure. That's it. Thank you one and all for your patient listening.